Okay, so this video is going to cover still Chapter 6, Section 3, but it's going to be Part 2. Today what we're going to talk about are the altitude slides. So on Friday we talked about the medians, their point of concurrency, which was the centroid. We learned the centroid theorem, that the distance or the length of the median from the vertex to the centroid was 2/3 of the length of the whole thing. And then from the centroid to the midpoint, that was the 1/3 piece of the median. We did some examples. And now today we're going to talk about the altitudes of a triangle. So an altitude of a triangle is the perpendicular segment from a vertex to the line containing the opposite side. Every triangle has 3 altitudes. An altitude can be located inside, outside, or on the triangle. Now, when you probably did area formulas or questions in middle school, you probably were looking for the height of a triangle. The height of the triangle is the same thing as the altitude. So we're going to be looking for a perpendicular segment that's going to indicate an altitude. So just like the perpendicular bisector, it also has a right angle associated. So the next thing we're going to talk about is the orthocenter. The orthocenter is going to be the point of concurrency where all of the altitudes meet. So the lines containing the altitudes of a triangle are going to be concurrent, and that point of concurrency is the orthocenter. So in this picture, the red lines are the altitudes, and the point that's labeled as G is the point of concurrency, and this is called the orthocenter. Now, if you were ever asked to draw in altitudes, if you're doing it on a piece of paper, it's a lot easier to rotate your paper so you can draw in that perpendicular segment. If it's your iPad, maybe do lock screen or just try to turn your iPad so you can draw them in. Let's try an example. So again, a coordinate plane has been provided. Let's go ahead and graph these 3 vertices. So the first one is X, and it's the ordered pair -3, -4. I'm going to come over here. This is coordinate or vertice X. Then I'm going to graph -3, +4. And that'll be Y. And then lastly, +5, +4. And this will be Z. I can go ahead and connect the vertices to form my triangle. Notice I've got a horizontal and a vertical line. That's going to form a right angle, so this is a right triangle. And the orthocenter, when it's a right triangle, is going to be located on the triangle. So let's go ahead and draw in the altitudes. When you have a right triangle, the altitude that goes from point Z over here, this is going to be one of the legs. Same thing here, this leg is also an altitude. And then the final altitude would be from vertice Y to the other side. And again, if it helps you to rotate your iPad to draw that perpendicular segment, that would be the 3rd altitude. So when it's a right triangle, the orthocenter is going to be located at the right angle. So the orthocenter here is the coordinates for Y. It's -3, +4. So when it's a right triangle, the 2 legs of the right triangle are altitudes. So the point of concurrency is going to be where that right angle is located. So here the orthocenter is -3, +4. So this is a right triangle. So the orthocenter is on the triangle. So again, here's just a summary slide. So the location of the orthocenter depends on the type of the triangle. So when it's an acute triangle, it will be located inside the triangle. In all three of these pictures, point P is the orthocenter. Again, you can see for the right triangle, it's located right here at the right angle. All of the red lines are the altitudes. Then for the obtuse triangle, this is when it's located outside of the triangle. The original triangle is created with the black lines, and then again, the altitudes are the red lines. So remember, when it's a right triangle, the two legs are going to be the altitudes, or two of the altitudes. And you could draw in the third one if you need to. And then the last slide is just a summary of all of the we've talked about in chapter 6. We talked about perpendicular bisectors. Their point of concurrency is called the circumcenter. We talked about angle bisectors. Their point of concurrency is the incenter. We talked about medians. Their point is the centroid. And lastly, today we talked about the altitude, and the point of concurrency is called the orthocenter. So be able to find these points of concurrency. And again, you can find them by graphing them. But if you don't know how to draw in a perpendicular bisector or an angle bisector or a median, then that's where it's going to get to be a bit challenging. So again, maybe, make some kind of summary notes for yourself. More than likely, your quiz will be on Lockdown Browser. So if you are going to use notes, you're going to have to handwrite them or print them out. So you will not be able to use your iPad for notes. You're going to have to handwrite them for Wednesday, okay, or print them out. My advice to you, though, is don't try to print out every single packet of notes. It's going to be wasting lots of paper. It'll be a lot better if you can make yourself an outline for the chapter, okay? Any questions? All right, so let's go ahead and take a look at your homework. Now, in the textbook, there wasn't very many questions that involved orthocenter. I could only find 5. So what I've done today is I've taken those 5 questions and I've also added them to the quiz review. So let's go ahead and take a look and see what your homework is.